Hi, my name is Fatin Afika. It acts as antibiotic and bacteriostatic. It is no longer produced as a single agent due to bacterial resistance. This drug is now used primarily with trimethoprim in ratio 5:1 to reduce the development of bacterial resistance to the drug. It is used on Streptococcus, E. coli, Haemophilus influenza, and oral anaerobes.
My name is Irene. For the ATC code, letter J refers to level of anti-infective for systemic use. J01 refers to antibacterial for systemic use that destroys the bacteria. J01E is the combinations preparations of sulfonamides and trimethoprim. J01EC consists of sulfonamides with biological half-life of 11 to 12 hours, and the general ATC code of sulfamethoxazole is J01EC01. Now let's move to the label structure of this drug. It consists of benzene sulfonamides, sulfonyl, ethylene, and isoxazole. The key functional group of this drug are primary amine, oxazole, secondary amine, and benzene. In biotransformations, sulfamethoxazole will be converted to N4-acetyl-5-OH sulfamethoxazole since it undergoes extensive metabolism mainly by several oxidative pathways. While in allergic reactions, sulfamethoxazole will be converted to sulfamethoxazole N1-glucuronides by CYP450.
Hi, I'm Chang Zijin. It's my turn to discuss about drug protein structure. Overall structure. It is a large-sized protein which is also the pocket dihydropteroid synthase. It is a very important protein for the bacteria. Ligand and pocket. This figure takes from the PDB 3D viewer. The drug sulfamethoxazole is the ligand and the pocket is the protein. The drug sulfamethoxazole actually hides inside the pocket, and hence it needs to be rotated in order to see the drug. This figure has been enlarged many times and sulfamethoxazole resides in the pocket nicely. Next, the ligand-protein interactions from literature. Now let us take a closer look at the ligand-protein interactions. Generally, many amino acids on the dihydropteroid synthase can interact with sulfamethoxazole through hydrogen bonding. However, the important binding interactions that give the therapeutic effect is the binding through threonine, serine, and proline. Upon binding, sulfamethoxazole, which is structurally similar to para-aminobenzoic acid, prevent the binding of para-aminobenzoic acid to the protein, hence preventing the bacterial folate pathway.
Assalamualaikum, I'm Ghazali. The minimization energy of it is 65.176. The left side is before minimization and the right side is after minimization. It shows stick style and ball and stick style.
I'm Veronica Anakwe. So basically, I will talk about the molecular weight, HBD and HbA of the sulfamethoxazole. Its molecular weight is 253.28 gram per mole. I will talk about the HBD and HbA. For your information, HBD is hydrogen bond donors and HbA is hydrogen bond acceptor. As you can see in the picture, there are two HBD present in the molecules. Both are amine groups which are bonded to benzene ring and oxazole ring. There are three HbA which are the oxygen and nitrogen atoms in the oxazole ring and the sulfonyl group.
The value of molar refractivity obtained from calculation is deviates slightly from the theoretical value, which is 62.45 cm3. The differences is might caused by the number of the decimal used during. pKa value for sulfamethoxazole obtained can be classified into strongest acid and strongest basic. For strongest acid, the value is 6.16, meanwhile the strongest base is 1.97.
Hello, my name is Nur Fitri. Now I'm going to tell the solubility of sulfamethoxazole by using Lemke's formula. To calculate the solubility, first of all, we need to identify the functional group that present in the structure of which can be found from the Lemke's formula table. The structure shows there are 3 amine group and 1 ethyl group. Then, we need to calculate for each monofunctional molecules and polyfunctional molecules. Here is a table for the calculation. Based on monofunctional molecules calculation, it is shown that it is water-soluble molecules. Same goes to the polyfunctional molecules calculation. Since sulfamethoxazole contains more than one functional group, so the result from the polyfunctional molecules calculation is more reliable. Hence, sulfamethoxazole is a water-soluble molecule based on Lemke's formula.
First, optimization by increasing solubility. The oxazole ring previously attached with the methyl group is replaced by the hydroxyl group. The hydroxyl group plays a very important role in hydrogen bonding by replacing to the hydroxyl group. The total number of hydrogen bond acceptor HBA increases from 3 to 4 and the hydrogen bond donor rises from 2 to 3. This increases the water solubility of the drug, which the log P equals to 0.74, lesser than the original 0.89.
Hi, my name is Narmata Balakrishnan and I am going to explain to you about how the modification of the drug can actually increase its lipophilicity. And what we have done here is that we have replaced the oxazole ring and methyl groups with a benzene. And when this took place, the calculated amount of log P value increased from 0.89 to 1.55. This definitely shows an increase in the lipophilicity. Lipophilicity tells us about the compound's ability to dissolve into lipophilic solutions. This is very essential for the compounds to actually go through the biological membranes. And this modification shows a higher hydrophobicity. We know that the hydrophobicity of a drug is inversely proportional to its log P value. And when the hydrophobicity increases, a higher protein binding will occur, and this causes only the unbound drug to be metabolized, while the rest of the drug dissociates more and more from the protein plasma. This causes more drugs to be metabolized and increases the half-life of the drug.
Assalamualaikum and hi, I'm Ala Shahira. Based on the modification by our own logics, we have changed the functional group of methyl to trifluoromethyl in oxazole ring. Basically, this replacement of hydrogen to fluorine may prevent metabolic oxidation of the site and increase half-life of the drug. This is called bioester, which is the substituent in a particular compound of a similar physical or chemical properties which will produce a broadly similar biological properties. In addition, it also improves stability in terms of hydrophobic, high electronegativity, and size. Hydrophobic characteristic of trifluoromethyl make it drug to infiltrate in the body and reach its target site of action. High electronegativity between carbon and fluorine make combination of lipophilicity and stability of this drug proved by log P of ChemScat, which is positive 2.18. The size of this modified drug can mimic with respective requirements at a receptor site.